Hi everyone, this is the Nordic Venture Show, your guide to the exciting world of Nordic startups and venture capital. In today's episode, we're exploring a startup called Flow Computing.
Okay, so imagine this. What if every single thing on your computer, your phone, even like that smart toaster you've been looking at, could run like 100 times faster?
Wow.
Seriously, we're not talking about like some crazy sci-fi thing. This is real. We're diving into Flow Computing and their super CPU tech.
Yeah, I've heard of these guys. They're the ones with the PPU.
Exactly.
Yeah.
We've got a whole stack of press releases, articles, even stuff from Flow's own website.
Oh, yeah, I was reading some of that.
And let me tell you, this could be huge, like seriously huge.
Potentially.
But here's the thing. We're not just going to like sit here and geek out on the specs, right?
Mm-hmm.
We want to understand like why this matters to you. Like think about it. AI that actually lives on your device, not in some like data center far away.
Right.
Think about like self-driving cars making split-second decisions, no lag.
Yeah, that would be amazing.
That's the kind of future that this tech could unlock, and that's what we're going to unpack today.
Yeah, let's get into it.
Okay, so first things first, what exactly is Flow Computing?
So they're this Helsinki-based startup, and, they're not just like making small improvements. They're really trying to like revolutionize processing power. You know what I mean?
Yeah.
And what's really interesting is that they're not trying to just like replace your CPU entirely. Their secret sauce is this thing called a parallel processing unit, or PPU for short.
Okay.
And it works alongside your existing CPU.
Alongside?
Yeah, so it's not like replacing it. It's working with it to unlock all this like parallel processing power on a scale we really haven't seen before.
Hold on. Parallel processing, for those of us who aren't like chip heads?
Sure. Yeah.
What does that even mean?
Okay, so imagine your CPU is like a one-lane road, right?
Okay, one lane?
Cars can only travel one at a time.
Yeah.
Even if they're like super fast cars.
Right.
There's a limit to how much traffic can actually flow through.
Sure.
The PPU is like suddenly adding 100 lanes to that road.
Wow.
So more cars can travel at the same time.
Right. You
drastically increase the overall flow of traffic, or in this case, like data.
Okay, so 100 lanes of data. That's a pretty vivid image. I like that. But wouldn't we need like completely new software to even take advantage of that?
That's the really clever part.
Okay.
Flow designed the PPU to work with both like the new stuff and the stuff we already have.
Oh, wow.
Yeah, like they have an article where they say you can get a 2x speed boost on old code just by recompiling it for the PPU.
Really?
Yeah, so we're talking about boosting performance of everything you know, from your everyday apps to those like really complex simulations.
That's what I call backwards compatibility.
For sure.
But wait, they're even going after RISC-V? We saw that in one of the articles?
Yeah.
They're not messing around.
No, they're not. That's a big deal because RISC-V is open source, right?
Right.
It means anyone can use it, anyone can modify it, and it's kind of seen as a challenger to the big guys like Intel and ARM.
Uh-huh.
So flow targeting RISC-V, I think, means that they're thinking really long-term. Aiming for compatibility with like a whole range of devices that might come out in the future.
And they're seriously hiring for this project. We saw job postings for all kinds of engineers, from compiler people to CPU modeling gurus.
It's exciting stuff.
It's not just a concept. They're putting serious money behind it.
Definitely.
But let's be real here for a second. A 100x speed increase? That sounds like a little too good to be true.
Yeah, it is kind of hard to believe.
One of the articles we have, I think it was TechCrunch, they even called it one of the wildest claims they've ever heard. I gotta admit, I'm a little skeptical.
Well, it's always good to be conscious with any new tech, right?
Right.
But here's the thing. Flow isn't just like making this up.
Okay.
Their PPU is based on a ton of research from the University of Eastern Finland and this place called the VTT Technical Research Center. Both of those are like super reputable places.
Okay, so there's some real science behind it.
Yeah, for sure.
But even with all that amazing research, it's not just going to be plug and play, right?
Well, you're right about that. To get that full 100x, they're going to need developers to optimize software, like specifically for the PPU.
So it's a team effort.
Yeah, for sure. It's not just a magic bullet.
So it's not just about faster chips. It's about a whole new way of thinking about how we write and run software.
Exactly. It's a potential paradigm shift. Like a fundamental change in how we even approach computing.
That's where things get really interesting.
It is pretty fascinating.
All right, I'm hooked. Tell me more about why this matters. What's in it for me and for our listener besides a speed boost?
Well,
I mean, Flow's own website highlights some pretty wild possibilities. We're talking about running AI algorithms locally on your own devices, 5G and 6G multimedia editing on the go, even making self-driving cars safer and more responsive.
And those are just like the beginning.
Right.
What's really exciting is we could have whole new applications.
Like what?
Like imagine scientific analysis that takes weeks or months right now being done like instantly.
Wow.
Think about personalized medicine tailored to your DNA.
Oh.
The PPU could unlock things we haven't even thought of yet.
Wow. Okay, now I'm starting to see why this is such a big deal. This isn't just about speeding up what we already do. It's about expanding what's even possible.
Exactly.
But hold on, before we get too carried away, we need to talk about the elephant in the room, the ethical considerations.
Yeah, you're right.
I mean, Flow's website says they're committed to sustainable computing and improving the safety and efficiency of the systems we all use.
Sure.
But there are always downsides to consider.
Oh, absolutely. With great power comes great responsibility.
Right, exactly. And even with the best intentions, you never know what could happen.
Yeah. Unintended consequences and all that.
Yeah, we need to be thoughtful about how this is developed and used.
I think that's a conversation we need to have, not just about flow computing, but about any new tech that could really change the world.
Absolutely.
It's about finding that balance between progress and responsibility.
Well said. So we've covered a lot in this first part of our deep dive. We've explored what flow computing is, how their PPU tech works, and why it has the potential to change everything.
Yeah, for sure.
But we've also touched on the ethical side, the potential downsides, things we got to be mindful of.
Definitely.
And that's something we'll keep digging into as we go deeper into this topic.
It's going to be interesting.
So buckle up, because in the next part of our deep dive, we're going to take a closer look at Flow Computing, the company, their journey so far, and the challenges they might face as they try to bring this revolutionary technology to the world.
Sounds good. It's interesting how Flow's approaching this whole thing. Like, it's not just about building a faster chip, it's about building a community.
Yeah, I was noticing that too. Their website is full of resources for developers, white papers, even a whole podcast series with Professor Dr. Jorg Keller, who dives into all the technical stuff. They're really trying to be transparent and get people excited about the PPU.
It's a smart move. The more developers they can get on board, the more amazing apps we'll see. And that's what's really going to drive the demand for their super CPUs.
Totally. It's like they're saying, hey, we built this incredible tool now. Let's build the future together.
Exactly. And speaking of Flow's journey, I'm kind of curious about the team behind all this. Where did these guys even come from?
Well, according to their website, the founders are Timo Valtonen, Marty Forsell, and Jussi Roivainen. And they've got a good mix of, business, technical, and design expertise.
Okay.
Plus, they've got a really talented team of engineers and specialists, folks like Andrea Coluccio, Angela Werner, Gabor Martinen, and a ton more. It's clear they're attracting some top talent.
It's impressive how fast they've grown, especially considering they just came out of stealth mode.
Yeah.
Remember those articles we saw from June 2024?
Yeah.
Announcing their $4.3 million funding round?
Uh-huh.
That seems like that was their big debut.
Yeah, and they've already been recognized for their work. In March 2025, Flow Computing was named one of Finland's 10 most interesting startups. Oh, wow.
By Talousalemme, which is a pretty big Finnish business publication.
Okay.
Seems like the world is starting to take notice.
Finland has a pretty good track record when it comes to tech and innovation,
Yeah.
That kind of recognition can really help them attract investors and partners, which is super important for a startup trying to make a global impact.
Definitely. And speaking of global impact, let's talk about the applications of this tech. We already touched on a few, but their website hints at a much wider range. They mention everything from edge and cloud computing to AI clouds, multimedia processing, autonomous vehicles, even military-grade computing.
Wow. It's like they see the PPU as a fundamental building block for the future of computing, applicable to every industry.
It's like they're handing us the key to a whole new world of possibilities. But let's be real here. This is going to be a long road with a ton of challenges.
Oh, for sure. One of the biggest hurdles I see is convincing the big CPU companies, the Intels and the ARMs of the world.
To actually adopt this technology.
Yeah.
It won't be easy to persuade them to change everything.
Right, especially since Flow is basically proposing a paradigm shift, a fundamental change in how we think about CPUs that requires a massive investment of time and resources.
Absolutely. They'd have to change their designs, their manufacturing processes, their whole ecosystem.
Exactly. And don't forget the challenge of building a strong developer community around the PPU.
Right.
Without software support, its potential is pretty limited.
Definitely, Flow needs to give developers the tools and resources they need to create amazing applications that really take advantage of this new architecture.
So it's not just about the tech itself, it's about building a whole ecosystem around it. That's a tall order. But if they pull it off, the rewards could be huge.
For sure. Imagine a world where our devices are not just faster, but they can do things we can only dream of right now.
Yeah.
A world with real-time complex simulations, personalized AI, where the limits of what's possible are constantly being pushed.
It's kind of overwhelming to think about, but let's shift gears for a second and talk about the potential downsides we already touched on, the ethical considerations. But are there any other risks or challenges we should be thinking about?
Well, one concern is the potential for increased complexity.
Huh?
Parallel processing is just inherently more complex than traditional serial processing.
Yeah.
It could make it harder to design, debug, and maintain software for the PPU.
That's a good point. And with more complexity comes the risk of more security vulnerabilities.
Exactly. As we rely on more powerful and complex systems, security becomes even more important. Flow's going to need to make sure that the PPU has really robust security measures built in.
And what about accessibility? Will this be available to everyone or only to those who can afford the latest hardware?
That's a big question. We have to remember that tech can sometimes make existing inequalities worse.
Right.
Flow needs to be aware of these issues and make sure their tech is accessible to as many people as possible.
So it's not just about speed, it's about making sure the benefits of that speed are shared by everyone.
Exactly. We have to think about the impact this tech could have, both good and bad. It's not enough to just focus on the cool possibilities we need to address the potential problems, too.
Well said. We've covered a lot of ground in the second part of our deep dive. We've explored flow computing's journey, the challenges they're facing, and the potential risks of this powerful new technology. But in the final part, I want to step back and look at the big picture. What does the emergence of flow computing tell us about the future of processing power? And what does it mean for us as we live in a world that's becoming more and more digital? As we wrap up this deep dive into flow computing, I feel like we've only just scratched the surface,
Yeah, you mean?
This isn't just about like a startup or a new chip. This is like a glimpse into the future where like the whole idea of computing is changing.
It really is. We've gotten so used to the limits of CPUs
Right.
that it's like hard to imagine what it would be like to just break free from that.
It's like we've been living in a world of dial-up. Patiently waiting for pages to load, and then flow computing comes along and says, hey, here's fiber optic speeds for everything.
That's a perfect analogy. And just like the internet changed everything, communication business.
Yeah.
This kind of crazy leap in processing power could have a huge impact on so many other things.
Totally.
What really gets me excited is how it could transform scientific research. Like, imagine climate models that run in real time.
That's a game changer.
It is. We could make much better predictions and come up with better solutions.
We could actually do something about climate change that wasn't possible before. And what about healthcare? Personalized medicine based on your own DNA, analyzed instantly.
It's mind-blowing.
The possibilities are endless.
They really are.
It's like Flow is giving us a blank canvas and saying, here's the power now, go create something amazing.
I like that. But it is a little daunting.
Yeah.
Because like we've been talking about, with this kind of power comes a lot of responsibility.
You can't just get caught up in the excitement without thinking about the downsides.
Right.
We have to talk about the ethics, the potential for misuse,
Yeah.
Making sure this technology helps everyone, not just a few.
I totally agree. And that's where our listeners come in.
Right.
This isn't just for tech people or politicians.
Right.
We all need to be part of this conversation.
Yeah.
Stay informed, ask questions, challenge assumptions. The future is being shaped now, and we all have a role to play.
So well said. As we finish up this deep dive into flow computing, I hope you're feeling a sense of wonder, a sense of what's possible, but also a sense of responsibility.
Definitely.
Flow computing is a bold bet on the future of processing power, and it could unlock so much.
You could.
But it's up to all of us to make sure this power is used for good, ethically and for everyone's benefit. Thanks for joining us on this journey. And until next time, keep exploring, keep asking questions, and keep pushing the limits of what's possible.
Thanks for listening to the Nordic Venture Show. Don't forget to subscribe and stay tuned for more stories of innovation from the Nordics.